On this video, I'll be showing you how to carry out measurement of distances, that is distance between 2 points, using your survey master. So two methods we are going to be talking about is, first off, let's go to our tools page and then we'll click on Kogo. Now on Kogo we'll select 2 points, so we are measuring the distances between 2 points. Now the first method to do this is that you've already surveyed the point and then you have the point on your coordinate list. So if I want to select the point from my coordinate list, I'll go to element, click on my points, and let's say I want to calculate distance between 0.5 to 0.7. So I will select 0.5, click on confirm. The coordinates and the details for 0.5 will appear on the list. For my second point, which is the end point, I'll also go to element and then I'll select 0.7, which I'm using as my end point. So as you can see, I have my 2 points already. When I scroll down, it will give me the azimuth. Azimuth is the forward bearing from 0.5 to 0.7, which is 26 degrees, 44 minutes, 80 seconds. The horizontal distance is 6.179. The 3D distance, which is referencing the height, is 6.18, and then the vertical distance is just 0.1337. So these are the details for the distance between 0.005 and then 0.007. Now another method to calculate these 2 points is to do direct survey. Also, you can also select from your map if you do not know the actual point you want to use. So for our point 1, I'll go to map. It will show me the map screen. So from here, I can just click the point I want to use as my first point. So let's use point 4. Click on point 4, click on confirm. For our second point, I click on map as well. I'm using 0.7 now because I think that's the longest line we have here. So click on confirm. So azimuth, which is the forward bearing for 0.4 to 0.7, is 32 degrees, 30 minutes and 47 seconds. The horizontal distance is 10.906. The 3D distance is 19.595. Vertical distance is 16 meters. So as you can see, these are the details on the distance between 0.4 and 0.7. Also, the last method is that I do not have the points direct already. I have not surveyed the points, so I want to do a direct survey. Now for that, I will still click on my 2 points. Now for my point 1, I will, instead of clicking on element or on map, this time I'll click on survey. So I'll click on survey. I'll take my instrument or my rover to the point where I want to measure as point 1, and then I'll click on start survey. So it's telling me that IME is not on, so I need to go and calibrate my IME. So let's go back to, I need to go to topo survey to do the calibration. So just to shake, our IME is set. Now we can go back to Google and do our distance calibration. So on survey, I'll click on start survey and wait for 5 seconds, the same way it does on topo survey. So it has given me the point 1. I will move again to a second point, which is the end point. When I get to my end point, I'll click on survey as I did for the first point. Click on start surveying, wait again for 5 seconds, and so I've gotten my second point. Now when I check the details of the measurement I've done, the forward bearing from point 3 QP3 to QP4 is 351 degrees, 17 minutes and 21 seconds. Also, the horizontal distance is 6.0767, and then the 3D distance is 6.077, and finally the vertical distance is 0.069. So this is how to calculate distances between 2 points, either from the points or your coordinate list, which you use the points you already have on the instrument, or you want to do a direct on-site measurement. So thank you very much. On this video, I'll be showing you how to calculate your area. So probably you've gone to site and then you've done a survey of 4 or 5 or 10 points according to the shape of your land, and you want to calculate the area for the points that you picked. All you need to do is you go to the tools page, which is the last page, and then you click on area calculator. Now when you click on area calculator, you are going to need to select or import the points that you want to use to carry out the calculation. So what you do is you click on add. Now if you click on map, it will take you to the topo survey page, and then you'll be clicking on the points that you want to use for the calculation one by one. So these are points I have. If I want to calculate for 5, 4, 6 is here, and 11 is also here. I'll just be clicking on the points as I want. So I'll touch 4. If I go down to 11, click on maybe 7 is on top, and then I click on 5. Click on confirm. I've gotten 4 points, so 4, 11, 7 and 7. What I will do next is to click on preview. Now this is the shape of the points that I selected that I want to calculate area for. And when the shape is okay, I'll go back and then I'll click on compute. So this is the area, the area within the points that I selected. Another method is, let's clear this list. Another method is, if I want to add my points, I'll go to element and then add 5, 6, 7, 8. Click on confirm. Let's preview this. So see the shape for points 5, 6, 7, 8. If you check, 5, 6, 7, 8 is picked in a serial form, so it is well arranged. Another thing might happen if you do not pick your points in a clockwise direction. You can have something like this. You see, the shape is no longer correct. It's giving us 2 triangles, so you be sure that your points are well arranged before you click on, and then you preview. After you've seen that your shape is correct, you can now click on compute, and then you get your area. So this is how to calculate area using either selecting the points from your map interface, or you select the points from your coordinate list. So thank you very much. On this video, we'll be showing you how to calibrate your RMU, which is also the tilt compensation of your receiver. Now if you check on our screen, we've created a project already. We've connected to our base station. We've set up our Datum, which is our coordinate system, and everything is working fine, and as you can see, it's fixed. So to calibrate your IMU, you normally do that when you are carrying out survey. So we'll go to the survey page and then we'll click on topo survey. So this is the IMU icon at the right corner here. So but before that, you need to be sure that your height of pole is correct. So if you check your height of instrument, which is the antenna height, you see that we are using a 2-meter pole, so our height of pole height is at 2 meters already. So, and again, be sure to tick the pole height option. If you are setting up on your base station and you are using a tripod stand, you click on slant. But since we are using a pole, you select pole height and then we'll click on OK. See, we've set up our height of instrument already. So the next thing we will do is to click on the tilt compensation icon, which is the IMU. So when we click on it, it will ask us if our pole height is correct. So we'll just click on the pole height is correct. If it's correct, if it's not correct, you click on edit to readjust your pole height. So now that our pole height is correct, we'll click on pole height is correct and then we'll continue. Now it will ask us to shake the receiver. So we just shake back and forth and that's it. See, now it's showing green color and then it's active. And then if you check the register icon, which is the button that you use to pick points, the level of tilt is also showing underneath. So if I bend the pole, the angle at which it is tilted will be showing there. So that's how to calibrate your IMU. Also note that there are some receivers that will ask you to not only shake back and forth, they will ask you to rotate and others. So we'll just follow the steps and the processes that it's asking you to go, and then with that you can successfully calibrate your IMU. In this video, we'll be showing you how to pick point on floats. So if you check, our receiver is set up now, we've connected to our base station and it's fixed. Well, for the sake of this video, I'm going to disconnect from the base station, or probably even when you're still connected to the base station and then you are not having a fixed solution. So what you do at this point is, when you come to topo survey and you want to pick a point, now that it's not fixed, when you pick a point, it will tell you accuracy can't meet the demand. So what you just do at this point is you go to settings And if you see on our settings, we turn on fixed, meaning we can only pick points when it is fixed. So what we just do is to turn off fixed for a minute, click on OK. So let's check that again. See, fixed is off. So now we can click on survey, and then it will pick the points that we want to pick. So that's how to pick a point even when your receiver is not fixed. Now, one thing you need to note about picking points when your receiver is not fixed is that it will not carry out any accuracy check for you. If you come to our settings here, you see our RMS and HRMS and VRMS is set to 0.1. It means that if your accuracy is above 0.1, it will tell you accuracy error. So now that you've turned off the fixed icon, it will not check any accuracy for you. So it is always advisable, it's always safe to turn on your fixed setup, so that anytime you want to pick points, you are sure that the points you are picking are accurate. That is for how to pick points when you're having a float solution. Now, how to pick points even when your accuracy does not meet your demand. So if you come to Topo Survey, now you can see that we have a fixed solution, but when we try to survey, it is telling us that accuracy cannot meet demand. Please check. Now, on the top right of the screen, you can see H and V. Now, this is the level of accuracy on the point you are getting at a particular time. So if you check, now we're having a flow solution, the accuracy has dropped drastically. So it happens most time when you are under canopy cover, you are probably under buildings, or the receiver is having difficulty tracking satellite signal, so your RMS will go down. So now it's fixed and our RMS has reduced, but still now we can pick a point because the RMS has reduced. But then that is just the accuracy settings that it has been giving us. So what you do at this point when you are trying to pick a point and it's telling you accuracy can't meet. Now, at this point, if you are trying to pick a point, and because the accuracy level is not low enough for you to be, you just come to your settings. Now, see the HRMS and VRMS settings. As you can see, it's just set to 1 cm, and it will be difficult for you to get 1 cm if you are working in very, very difficult areas like under tree covers and others. So what you just do is you adjust your settings. You can use this as 0.1 and also use the V at 0.1, and then you are good to go. So now we can be able to pick points at any time. So even though, but then the accuracy will not go below 0.1 that we set. So anytime you want to pick points and it's giving you that accuracy cannot meet message, just go and check your accuracy settings at the HRMS and VRS. So that's how to do that.